Gas. That's right. What comes to your mind first? That's right. Maybe oxygen gas. Oh, that's right. Oxygen gas. What about the second one you come? Oh, that's right. Okay. Ideal law of a gas. That's right. Which is PV over T. It's a temperature. Now it's the P1, V1, T1. Okay, it doesn't matter. Actually, we are looking for, most of the case, we are looking for what? The second volume. See? Something happened, what kind of volume we're going to get. Okay, that's what we're curious about. Okay, so, okay, which is a V2. So V2 equals, okay, obviously, you just use V1 first, the times. We're talking about, oh, that's right. So fraction times fraction. So we call actually temperature fraction first. It doesn't matter. So anyway, okay, temperature fraction and pressure fraction. Okay, so pressure, that's it. Okay, so pressure 1 goes on the top, so pressure 2 goes to the bottom. Temperature is the opposite. Okay, temperature. So we talked about that one already, right? Because the temperature goes up, then this volume is going to be going up too. Okay, that's why. Okay, so T2 was on the top, then T2 to the bottom. That's it. That's right. This will help you a lot. Okay, so remember this one. Okay, so V2, which is the volume, so final volume maybe. Okay, is initial volume times pressure fraction times temperature fraction. Okay. Next one comes to your mind is STP. Very important, right? Okay. Standard temperature and pressure. Okay, we're talking about standard temperature first. Okay. That's 0 degree Celsius. Which is, we just convert this one to Kelvin. Okay, which is you add 273. So, which is 273 Kelvin. That's it. That's for temperature. Now, what about the pressure? So, talking about standard pressure, make it short. Okay, get to the point. Remember, that's it. So, 101.3 in kilopascal. That's it. Okay, let's look at this question. Very interesting question, right? Okay, right here, calcium carbonate, which is solid. That's right. So you can see this one, so one molecule, okay, 2 molecules of a hydrochloric acid with water, so actually that's hydrochloric acid solution right there. Then you mix with this one at STP. How about that? STP, standard temperature and pressure. Then we're going to have reaction right here. Calcium chloride, which is solid. Then we have a gas right here. Oh, carbon dioxide. Then water. Okay, that's it. Then, okay, actually, calcium carbonate, like this much amount, okay, 8.0, which is 80, but 8.0 times 10 and first power grams, okay, of calcium carbonate reacted with acid right here, hydrochloric acid. Then how much gas are we going to get? Oh, very interesting question. Number one, we have to make sure this reaction, which is a formula, is right or wrong. Okay, so calcium, 1 calcium right here, 1 calcium. Great. Now, what about C? Oh, so 1C, okay, on the left-hand side, right? Oh, 1C right there. That's good. Now, what about this time? So let's calculate how many oxygens. Okay, 3 oxygen right here, and 1 more oxygen, total 4 oxygens, right? Okay, now look at this one. Okay, 2 oxygens right here, and 1 times 2, that makes 2, so total 4 oxygens. Fantastic. Okay, what about chlorine? Oh, 2 chlorines right there. Okay, so we can see chlorine. Oh, chlorine, 2 chlorines. Great. Now, finally, so we check just the hydrogen, right? Hydrogen, 2 hydrogens, then 2 hydrogens, total 4 hydrogens. Okay, 2 times 2, which is 4 hydrogens. Great, that's it. Now also we have to figure this one out, okay? So what about 1 mole? 1 mole of calcium carbonate is how many molecular weight, okay, gram molecular weight, okay, which is calcium is 40 grams, okay, plus C, oh, that's carbon, right, which is 12 grams. So we know that. Okay, what about oxygen? That's right, number 8, oxygen is 16 times 3, 48. Ho-ho. So, okay, 1 mole is actually, if we add everything, 100 grams. But actually we used just 80 grams. That means, wait a minute. That means actually we can see this one clearly. Okay, 0.8 mole. Okay, that's, okay, 0.8 moles. That much we used. So that means clearly we can see we used only 0.8 moles, not 1 mole. Okay, so not 1. That means, hey, look at this one. That means this one is 1.6 because double. This one also 0.8 moles. This one is 1.6 moles. Okay, here the same thing. This one is 0.8. This one 0.8 moles. This one, okay, 1.6 moles. Okay, but okay, at STP condition, standard temperature and pressure condition, so we're going to have all gases. You know that, right? Okay, so 22.4 cubic decimeters. Oh. Okay, remember one more, very important right here, okay? All gases, that's right, all gases, 22.4 cubic decimeters at STP. That's right. That's right. This one is all gases 1 mole. Okay, 1 mole of all gases, 22.4 cubic decimeters. So now that's 1 mole, but as we saw this one only 0.8. That's why we just multiply 0.8, which is, as you see, the answer is 17.92 cubic decimeters, which is about 18. We can say 18.0. That's what we're going to use. How about that? Okay, decimeter. Now, the volume of CO2, which is a carbon dioxide, should be 18 cubic decimeters, but that was at STP, which is at STP. So now we are looking for final volume, which is like a volume 2, which is first volume, which is V1 times, okay, then a fraction of pressure, okay, which is pressure goes, P1 goes on the top, then P2 goes to the bottom. How about temperature? That's right. We were talking about this one already many times. Okay, it's the opposite. So T2 goes on the top, then T2 to the denominator. Okay, now, but we all know that after a chemical reaction, the temperature is going up, okay? So then P2, also pressure are going to be changed, right? Okay, usually going up or down, okay, so depends on. Okay, now temperature too also different. So at this point, okay, this is going to be 22, let's say 24 degrees Celsius, that's temperature. Then automatically we got to change this one to Kelvin anyway. Okay, what about pressure? Pressure changed a little bit too, 98.3. How about that? 98.3, okay, kilo Pascal. So on this, we're going to add 273, so 297 Kelvin, right? Okay, all we have to do is just plug them in. Okay, 18 cubic decimeters times Okay, P1 goes on the top, right? Okay, just like this. Okay, then 101.3 kilopascal. Okay, what about P2? 98.3, 98.3, okay, kilopascals times, okay, temperature. That's right. So T2 goes on the top, right? So 297 K over 273 K. Fantastic. So we reduce this one, K. What about this one? So we can reduce this one. Then we calculate everything. It's going to be, that's right, cubic decimeter going to be left over. Then actually this answer going to be 20 cubic decimeters, which is 2 times, maybe 2.0 times, okay, 10 to the first power. That's it.